Good morning, everyone. My name is Deirdre Denman, and I'm the Marketing Coordinator for EandM. Thank you for attending our webinar today titled Hottest New Trend for Inline Inspections. For a portion of the webinar this morning, you will need to listen through your computer speakers. Those listening through their phones will need to make sure that their computer audio is turned on. After the webinar this morning, we will be doing a short Q&A. Please type any questions or comments into the Q&A box, the chat box, or email us at webinar@eandm.com. I'd like to introduce your presenter for today, Akshay Bhati, Sensor Product Specialist with EandM. And without further ado, I would like to turn it over to Akshay to get us started. Good morning, Akshay.
Good morning, Deidre. Good morning, everyone. My name is Akshay Bhati, and I work as a product specialist for SICK Sensors, looking after NorCal region. Before we jump into the content of the webinar, I would like to give you a 1-minute overview of EandM for those who aren't familiar with us. So EandM is the West Coast leader in automation, and we represent a variety of automation lines like SICK, Siemens, Balluff, and so on. Our headquarters is in Hillsburg, and we have 2 offices in California, one in San Francisco, and our second office is in Irvine. We recently opened our Northwest office in Portland, and we'll be opening another office in Seattle. So one of the primary goals of EandM is to have shortest lead time of parts. To make that happen, we stock around 160K parts at our West Coast warehouse, and we ship around 1,400 parts on an average each day. This is EandM's inside sales team, who has won several awards for their excellent service. 85% of the quotes are sent within an hour, and 98% of the quotes are sent the same day. EandM has 4 full-time tech support engineers to answer all your technical questions right away. No waiting, no voicemail, no communication confusion. All the answers are answered live, and you don't have to go through any communication emails. We offer around 32 training classes and 15 free workshops in 1 year. And if you're interested in that, then please go to our website and register for it. Our next SICK safety workshop is scheduled for next week in San Francisco office. Once again, if you're interested, please go to our website and register for it. So we have our first roadshow coming up in Pacific Northwest region, where we'll show you latest technologies to help you take your next step towards digital transformation. So now we'll go ahead and get into the content for which you guys came here to learn, one of the hottest new trends for inline inspections. So a vision solution is something which cannot be installed and implemented right away. It has few challenges, and irrespective of the fact what technology it is, there will be few challenges for sure. So let me start with 3D vision system. The foremost challenge in 3D vision system is the cost. It's so expensive to buy this whole vision system. So that's the foremost challenge. But after we get this approved and we get the vision system in the facility, the next challenge is how to set it up, how to implement it in the system. So that requires special programming, and for which we need a specialized vision expert to integrate the vision system in your system. So if we move on to 2D vision, these types of challenges are not there, but there are 2 other challenges. The first one is it needs constant readjustment during the line changeovers. And second, it doesn't give enough data. For instance, if we have to do a detailed inspection, we are missing one data, that is a Z-axis, for which we have to install multiple 2D cameras, or we need a full-blown vision system. So to overcome all these challenges, we came up with a new sensor called TriSpector. TriSpector is a 3D vision sensor which works for 3D inspections for moving parts. And this sensor works on a principle of laser triangulation. So these are the key features of TriSpector. First one is that this sensor is used for 3D inspection. It gives more data as compared to a 2D camera. That's the Z-axis. And second, it has intuitive setup. So there are variety of tools and all those tools can be used for different applications. Third, it's affordable. So as compared to a vision system, this camera is half the cost of the vision system, but it gives equivalent features like a vision system. And fourth, it works really great with little contrast objects. And I'll show you in my further demos how it works really great with those objects. Now I'll show you a video where I'm using a SICK software called SOPAS. With the help of the software, I get a 3D reference image of the target where I'll be using different tools based on my application. And then I'll save the reference image to the camera's memory. And then I'll come up with the results, whether it's a pass or a fail. So this is my initial setup where I'm using a 4 bottles pack and I have TriSpector mounted on top of it. And now after I scan the object, I get a 3D reference image. So now I'll show you a video.
So this is the reference imaged form. It's a 3D image. And now we have a set of tools over here which will be used on this reference image, and then it will be saved in camera's memory. So we have 3 sets of tools over here. First is find. If we have to find something in an object, for example in our application it's the cap of the bottle, and the next subtool is inspect if we want to inspect something on the target, and the third one is measure if we need to measure distance or take a measurement of edge or any kind of measurement, then we go for this tool. So in our application we'll go and find, and then when we go and find we have different options. We'll go to blob tool. So what this does is we get a yellow area. This yellow area is our field of view only for the blob tool. So whatever blobs are seen in this area, you can see it over here. So it sees 5 blobs over here, and it gives us the coordinates of those blobs and the area. But our first blob we'll be using to count the number of bottles, and the second one we'll be using to see the separator if it's completely inserted or if it's present or not. So to make it into 2 blobs, we have to divide the blobs by changing the field of view. So over here I'll go and click this rotate button, see the side view, and then click arrow to change the field of view. Okay, so this is our blob 1, and now we are covering all the caps of the bottles and not including the separator. As you can see over here from the side view, you can see from the side view separator is over here and our caps over here. So we reduce the area so that we can exclude the separator and define it as a different blob. So if you go over here in the blob, you have settings. You can select the shape of the blob. It can be rectangle or ellipse. So in our case it's rectangle. Then we can select the blob area. This blob area in height range is basically that we are saying that the blob area should match this criteria to show this result. So in our case we just need to know the count of the blob, so we select blob 4. That means we are saying that okay, process the result, say it pass only if you see a certain number of blobs. So as of now it's looking for 0 blobs. The minimum we have to make 4, and then maximum 4, and now it will be pass because it sees 4 blobs. So this is the real blobs which it sees in the field of view, and this is our results criteria. So if we define the number of blobs over here with the minimum and the maximum range, then anything within that range it will consider as pass. So in this case, it's 4 minimum, maximum 4 because we are looking for 4 bottles. So as it sees 3 or 5 or 7, anything other than 4, it will consider it as fail. So this blob is defined. Now we'll select another blob for a separator. So again, we have to reduce the area, but over here, as you can see, we can also see the first blob. So we can ignore that blob by clicking this I button. Okay, I ignored that blob now, and then I should also name it as bottles. And this one as separator. Okay, so this is our separator blob. We have different settings over here. For this blob, I can see the height is 133.96 millimeters. Now, our goal is to see if the separator is present or not. Sometimes there can be a case when the separator is not inserted. So we need to detect it and say as fail. Second scenario can be when the separator is not completely inserted inside the box. So in that case, we can find out by setting a certain height, and when the separator is completely inserted, the height is 133.96 millimeters. So over here in the height range, I'll define a value. For instance, I'll say my maximum value should be 133.96, and this one can be, for example, 132. So if the 133.96, okay, it's rounding off to 134. So if the separator is not inserted completely, then the height will be more than 134, which is outside this range, and it will consider it as fail. And if there is no separator, then there will be no height in this region. The blob will be missing, so again it will be considered as fail. So in this case, z-axis is really important, otherwise you have to mount a second camera or you need a full-blown system to measure z-axis. So using these two tools, we can find out the number of bottles, we can count it, and we can, if the bottles are missing, then we can say that it's a fail, or if the separator is missing or it's not completely inserted inside, then again we can say it as fail. Now after we define our um, tools on the reference image, we save this reference image over here as job, and then I go to results tab, and over here I have 4 input outputs. So over here I've considered pin number 4 as device ready, or I can say it as overall result if it's okay or not. That means if everything is good, it's pass. Or so as of now I've just selected device ready. I can also choose overall result okay, and as soon as it sees or gets the complete result as okay, and then it will trigger an output. You can use this digital output to um, and connect it to a stack light or any kind of visual output for the operator to see that everything is fine. Now over here in the task, this is my 4 bottles job, and I've saved it and it's named as 4 bottles pack. I have another job that is 6 bottles pack, where I'm using 6 bottles. So there can be scenario where in a factory 4 bottles can come on a line, or 6, or 12 bottles crate. So in those cases, using a 2D vision, you have to save the reference image again. You have to worry about lighting, you have to worry about the colors of the cap or bottles, what's the contrast ratio. But with this sensor, you don't have to worry about that at all. You can do a complete line changeover just by a single input. Like as you see over here, these are two different recipes, 4 bottles pack, 6 bottles pack, and you can do a complete line changeover based on just providing an external input. So over here we have all the inputs and outputs. Our 3 inputs are fixed, pin 1, 2, 3, and 4 to 7 are flexible input outputs. So over here I've selected for pin 4 as output, which was seen over here. I've assigned it as overall result as okay, then trigger it on pin 4. So right now I'm not using these 3 inputs because I have only 2 jobs. So as you can see over here, with the job selection input for 4 bottles, if input 1 and 2 both are low, then 4 bottle pack job will be running on the line. If we have 6 bottle pack, then we need to change the recipe. So again, it's a complete line changeover. We just need to provide input to 1 as high and input 2 as low, and it will change the recipe immediately. You don't have to worry about reference image, lighting, low contrast, or any of those issues.
Okay, everyone. So that was the video of SOPA's tool. And as I said at the end, if we need to do a complete line changeover, then we have 3 digital inputs and 4 outputs, as you can see over here. And I'm using only 2 inputs, where for first recipe I do 0, 0, and for the second one 1, 0, and that's it. A complete line changeover, which reduces time. Now I'll show you product demos, which I did it in my office. So the first case is 4 bottles pack, which I just showed you. So this is the initial setup, and this was a 3D reference image of that target. I applied tools on this reference image, and the Z height, that is the height of the separator. I defined my limits. So the best case, when all bottles are present, caps are present, separator is present and fully inserted, the result is pass because it matches all the criteria. Second case, 2 bottles are missing, result fail, as you can see over here. Third, separator is missing, fail. Fourth, when separator is not fully inserted, this is the initial setup so that you guys can see the separator is not fully inserted, and result is fail because it doesn't match the height limits. So this is case 2, 6 bottles pack, and as you can see over here, the color of the cap was gold foil color earlier, and now it's orange. So there's a huge contrast difference, but the TriSpector is still mounted at the same position, no readjustment, and it still works fine and gets perfect reference image. 3D reference image. I applied tools. Result, pass when all the bottles are present, caps are present. Fail when 1 bottle is missing. Again, result is fail, 2 bottles are missing. So this is the initial setup where 1 cap is not there, and result is fail. It detects that 1 cap is missing. So just to recap about TriSpector, it's used for 3D inspection of moving parts, so it gives more data. And intuitive setup, as you saw the tools, we have lots of tools and we can use them based on our application. Third, it's affordable. It's half the cost of a full-blown vision system and gives us the features which are equivalent to a vision system. And fourth, it works great with little contrast. Thank you.
Thank you, Akshay. So at this time, we would like to open it up for any questions. Please type any questions into our Q&A box, chat box, or email us at webinar@EandM.com. We did have a couple questions that came in during the webinar. So the first question that I would like to ask that came in was, how much does the software cost?
Software is free of cost. You can download it from our website, sick.com.
The second question that came in is, what is the communication protocol?
It's Ethernet TCP/IP protocol.
And how many inspections can you do per scan?
You can do up to 32 inspections per scan.
And then the final question that came in through the chat box is, how would we image the chamber neck base of the bottle? Would that be possible in the setup that you did for the demo?
Image chamber, can you please repeat, what was that?
How would we image the neck or the base of the bottle in the demo that you showed? Would that be possible in the setup?
Yeah, that's possible. You can increase the field of view. As you saw in the video, I reduced the field of view just till the cap so that we can only detect caps. If you increase the field of view, you see the entire bottle. So based on neck or the base of the bottle, we have to define a field of view, and it will only look for that part of the bottle. So yes, that's possible.
Okay, so it looks like we don't have any other questions. So that will conclude our webinar for this morning. Thank you again, Akshay. If you would like to review any portion of the webinar, a recording will be available on our website at EandM.com this afternoon. And again, you can find more information about our future webinars on our website. And have a great weekend.
Thank you, everyone.